Bismillahirrahmanirrahim. Assalamu alaikum students. How are you? I'm sure you will be fine. Today the topic of discussion is nature of bonding and properties. At the end of the lesson, we will be able to describe the effect of different types of bonding on properties of matter, explain why ionic compounds have high melting and boiling points. As we have discussed in previous lesson that there are a number of type of bonding maybe ionic, covalent, metallic or weak intermolecular forces. So depending upon the nature of the bonding, the properties of the substance will be different. The stronger the bond, the higher the melting and boiling points and the hardness of the substance. In this lesson, we will discuss about ionic compounds and the bond which is present in ionic compounds and the effect of this bond on ionic compounds. I have a question for you. Why ionic compounds have high melting and boiling points? To answer this question, we have to discuss and examine the structure of ionic compounds. If we talk about the ionic compounds, ionic bond is present between ionic compounds. Ionic compounds are held together by electrostatic force between the oppositely charged ions. As the ionic lattice contains such a large number of ions, a lot of energy is needed to overcome this ionic bonding. So ionic compounds have high melting and boiling points. This slide shows the arrangement of ions in sodium chloride. Note that the sodium chloride forms colorless cubic structure. Each sodium ion is surrounded by 6 chlorine ions and each chlorine ion is surrounded by the 6 sodium ion. Thus in crystal, each ion is attracted strongly to each of the neighbor. The large attractive forces result in a very stable structure. So sodium chloride have high melting points. In the similar way, in cesium chloride, each cesium ion is surrounded by 8 chlorine ions and each chlorine ion is surrounded by 8 cesium ions. Thus in crystals, each ion is attracted strongly to each of its neighbors. The large attractive forces result in again very stable structure. So cesium chloride also have high melting points. So our chapter ends with this topic. Now we will discuss some review question of this topic. There is a 16 question. Some questions are very simple. The simple question will be solved by you and some questions are tricky. We will discuss these questions in this slide. And the first question is, describe the importance of noble gas electronic configuration. Actually, noble gas electronic configuration is easier to write because they are shorter than full electronic configuration. To understand the chemistry of any element, it's most important to know about the electrons in the highest energy level. It means valence shell. Okay. For example, lead has 4 valence electrons, and to know about its chemistry, we discuss only its outermost shell configuration. Recall the electronic configuration of sodium. Sodium has 11 electrons, and if we draw the electronic configuration, there are 2 electrons in S shell, again 2s and 2p6 and 3s1. We can abbreviate the electronic configuration by indicating the innermost electrons with the symbol of the preceding noble gas. Here the preceding noble gas with atomic number less than sodium is neon. So we rewrite the electronic configuration in this way, as you can see in this slide. So when someone asks you to write the noble gas electronic configuration of sodium, you would write the configuration in this way. So as you can see that now the outermost electrons is easily shown. So the chemistry of sodium can easily be understood, as we can predict that it has 1 electron in outermost shell. It means it's belonging to the group 1. It means the number of electrons in outermost shell indicates that it belongs to the which group of the periodic table. The next question is, find the number of valence electrons in the boron, neon, barium and arsenic using periodic table. You can see the periodic table in this slide. If we talk about boron, look at the third group. And the second period of the periodic table, boron is the first element of third period. As boron belongs to the third group, so it has 3 electrons in outermost shell. Similar way, if we talk about barium, and look at the periodic table and try to find out the barium. Barium belongs to the group 2. So barium has 2 electrons in valence shell. Similar way, if we talk about sodium belongs to the group 1, so it has 1 electron in the outermost shell. In similar way, you can find out the valence electrons of different atoms by using periodic tables. This is all for today's lesson. You have to do practice of review questions of chapter 4 from question number 2 to question number 8. Thank you. Have a nice day. Stay home, stay safe.